So I gave it a derivatives. Here's the first derivative. Here's the second derivative, right? And we figured out that this didn't have any restrictions on the domain, right? Because the denominator of this cannot be 0. The x-intercept was 0. The y-intercept was also 0. There were no other intercepts this time, right? Last time we left out one of the intercepts. This time, really, there's only one intercept. So that's another important clue. There's an asymptote. It's the x-axis. So it does seem to trail towards the x-axis. And remember, this is a vertical this is a horizontal asymptote, right? There is no vertical asymptote. This is the only asymptote that there is, and it's a horizontal asymptote. These are we determined to be maxes and mins, and we found this by, of course, setting the derivative, first derivative, to 0. We got those two values of 5 there. We tested them out. Well, first of all, the next thing we did is we got the points, CPs, and then we put them into I think this is the second derivative. Let me just double check. Yeah, put them into second derivative and found that when it was negative, that would mean that it was a maximum, and the other way around. This is a minimum, right? So that's what we figured out. Then we took this second derivative, set that to 0 again, and we found that we had 2 of these points that we had to look at. These are critical points. Critical points, remember, come from the first derivative. What we're looking at now is the intervals that we have to check for concavity, because that's what your second derivative is. So the 0 and the root 5 root 3, those were the intervals that we had to check, and we did that down here, and we didn't finish, and that's what we have to do now. So here are intervals. We go from minus infinity to minus 5 root 3, which is approximately minus 8. So we said minus 9 would have been properly in that interval. Then we took minus 1. I like 1. Whenever 1 is available, or minus 1, I always use it. So minus 1 here. I took 1 here as well. And I took 9 on the other side of that. Were there any other points that we had to include? I can't see the potential for this thing not to exist, unless you can think of one. I can't see any way that this thing is going to be undefined, right? So I'm going to say, because x squared plus 5 cannot be 0, right? There's no way for this to be 0. So this will never be 0. So therefore, this cannot be undefined. So I'm going to leave it at that. Okay, so help me out now, folks. I'm going to take this and put this into the second derivative, which is this thing right here. And let's figure out whether this part of the function is either concave up or down, and so on and so forth. So get your calculators out. I'm going to ask you for some help with this. All right, I'll repeat what I just said. This is my second derivative, what I'm pointing to right now. These are the intervals that we have to examine, starting from the left. I chose minus 9 because that's just to the left of this. This is minus 8 point whatever, I forget, whatever it is. So to the left of that would be minus 9. That's why I chose minus 9. In between 0 and this would be minus 1. In between here and here is 1. And this is approximately 8 point something. So to the right of that, I'm just going to choose 9. Okay, so I'm going to ask one of you just randomly for the result of putting this minus 9, this minus 1, this 1, and this 9 into my second derivative, okay? And here's a good time for me to bring out the wheel, because I like this thing to be fair, and nobody can sort of suggest that I am targeting them unnecessarily or unfairly, I should say. So let me open up my wheel for the class. I'm going to be calling on 4 of you to give me each of these, and let's hear how you do with that. So that's MCVQ2. That's you guys here. Okay, great. All right, so the first person that I'm going to be asking to do this, and it's just a matter of plugging numbers into an equation. That's all I'm asking you to do. And that first one goes to Umair. Umair, are you there? Let me start off with you. Check in for me first. I know that you're there. Okay, could I ask you to put the minus 9 into, let me make sure you're clear on what I'm asking you to do. Plug minus 9 into this function. If you have one of those really nice Casios, and I keep going on as if I have shares in the Casio company, you can just put the equation in and just keep changing the variable. But anyway, if you don't have a Casio, it doesn't matter. Put minus 9 into this. Okay, so you're getting minus 2700, you're saying, Omer? That's what you're saying you get when you put minus 9 into that function. Okay, so I'm going to say, and unless anybody objects to it, because I'm not checking this for myself, that you're saying that that part of the function is therefore negative. Okay, when you put minus 9 into that, you're saying that part is negative. I don't hear any objection from anybody, so I'm going to assume that Tom Leo says yes. Oh, look at that. A lot of people are in your corner on that one. Okay, so I'm going to take you out, and I'm going to be asking one of you now for minus 1. And that responsibility goes to Braden. Braden, I'm going to ask you to put, Braden, first of all, check in for me, please. So I know that you're there. Great. Can I ask you to put the minus 1, same thing that you just saw Umair do? Can I ask you to put that minus 1 into this function, which is the second derivative, and tell us the answer that you get? I'm mainly interested in whether it's positive or negative. I should be honest with you. The actual value isn't really. Oh, hold on. Kushi and Ariana seem to be disagreeing with the answer that I got earlier on. Is that right? So Tom Leah says it is minus 2700. Okay, we got a little bit of a. So you got negative. I got negative for the first one. Okay. Okay. So you're changing your, because I didn't check it myself. Right? So Ariana is changing what she said, and Kushi is okay. Forgot the minus 9. Okay. All right. All right. So it's negative. All right. Okay. So Braden, we're back to you. Put in the minus 1 for us, please, and tell us the result of putting in the minus 1. So minus x squared plus 7, exactly, it's right there. Let's tell us what you get when you do that, please. Excuse me. And again, mostly what I'm interested in, is it positive or is it negative? That's really what we're after right now. I'm assuming you have your calculator fingers working away over there, and we await your answer. Actually, I'm going to grab my calculator in the meantime and put my equation in. So minus 50 x bracket minus x squared plus 75. Okay, Braden says it's positive. Okay. Can I hear from the, oh, sorry about that. Can I hear from the rest of the room on that? I haven't put it in my calculator yet. Do you agree with Braden on that? Okay, so I'm getting positive on that. Do a quick calculation here with minus 1. Interesting. Okay, agreed, agreed, agreed. Yeses and yeses. Okay. Braden got a lot of people in his corner there, taking Braden out for now. Let's try this. I don't think that it always goes back and forth, back and forth. You just tell us what you get. And I'm going to be going now to Alicia next. Alicia, check in for me, please. First of all, are you there, Alicia? Alicia, looking for Alicia. Where's Alicia? Perfect. Alicia, can you put that 1 in for us, please, and tell us what you're getting with 1? And again, really just interested in whether it's positive or negative. That's really what we're after here. The actual value is of no real importance, not for this. And just for the record, what it is really telling you is the rate at which the first derivative is changing. That's all it is. And then I'll be asking for 9 after that. I can't say yet who that will be. Just waiting on Alicia's answer for when you put 1 in. Well, you should be doing it for yourself. So Alicia is coming up with a negative. And the rest of the room says yes or no. Yay or nay? What do you say, folks? Carly says yes. Tom Leah says yes. Vanessa says yes. Excellent. A lot of people are on that train there. And finally, thank you very much. Thank you very much, Alicia. And finally, we're gonna ask Christopher. Christopher, step up for me, please. Make sure that I know you're there first. Christopher, check in for me, please. All right, Christopher, put in the 9. And let's hear the result of putting in 9, please. They will interpret the results after that. Christopher, we've done this 3 times now. I mean, seriously, we've literally done this 3 times. So I'm asking you to put the 9 into the function that I'm pointing to now, right? I am asking you to do that, which we've done 3 times before. You got 2,700, which means that you're saying it's positive in that case. Now, that's what we're really after. The actual value is useful, but the thing that really significant for us is whether it's positive or negative. So you're saying it's positive, Christopher, and what do other people think about that answer? Does that kind of sort of make sense? Okay, Ariana and Colin, a lot of other people are, quick question, okay, why are we ignoring the denominator? Okay, that's a reasonable question, actually. That's a pretty good question. Okay, let's look at what this denominator is. X squared plus 25. My question for you is that ever going to be anything else except positive? Ashlan, let's think about that. Could this be negative? Could this thing that we're getting be negative? This denominator, what I'm pointing to right now, is it possible for it to be negative? What do you think, Ashlan? Right? If this has a possibility to be negative, then we have to consider both top and bottom. Absolutely, because of the x squared. When you square this and you add it to 25, right? There's no way that this is going to become negative. And you're going to raise it to the power of 3. Now, if there was a way that this could be negative, raising it to the power of 3 could also be negative, because you take a negative base and raise it to a 3, then it also becomes negative. But because this thing x squared plus 25 is always positive, it means that the denominator is always positive. So that's an excellent question to ask, and I'm glad you asked it. It's not always that you're going to ignore the denominator, but in this case you can, because the denominator will always be positive in this case. So that's a very good question to ask. Okay, so what conclusions can we draw now? Let's go back and see what we haven't filled in yet. Do we know our POIs? Do we know where it's concave up? Do we know where it's concave down? What conclusion does this lead us to? I'm throwing the question out to the whole class. Can anybody tell me what this result is telling us? Right? What can we discern from this result? Anybody? Not asking anybody in particular now. So I'm asking the whole class. Does this tell us anything? There are 2 concave up and concave down intervals. Absolutely. Min and max, Kushi? Not so much, because we already got the min and the max. Remember that the first derivative can tell us that, right? The first derivative, excuse me, which was this thing here that I'm pointing to, when we set that equal to 0, we got these 2 values of plus and minus 5. And what we did is we did put it into the second derivative. Or what do we do with it now? Yeah, I think we put it into this. No, what we did is we found the y values. Sorry. We found the y values here. Then we put it into the second derivative. And that's when we knew it was either a min or a max. Okay? It's the other test, right? Okay, so we're now thinking 2 concave up and 2 concave down sections. So remember, where it's negative is concave down. So from minus infinity to minus 5 root 3. So I'm going to put that in as a concave down section. All right, and again, not a lot of space here. Minus infinity to minus 5 root 3 is where it's concave down. And the other place where it's concave down, where the second derivative was negative, was from 0 to 5 over 3. So from 0, not 5 over 3, sorry, minus 5 root 3. All right, that part is concave down. So the rest of it would be concave up from minus 5 root 3 to 0, and from, I keep saying 5, yeah, 5, and from 5 root 3 to infinity. So let's put those in. So minus 5 root 3 to infinity, nope, to 0, sorry. Minus 5 root 3 to 0, and from positive 5 root 3 to infinity. Okay, that's okay, Kushi. As long as we've cleared that up, then that's good. Now let's get to what else this is telling us. Apart from the intervals of concavity, what else is this telling us? Does anybody know what else this table from the second derivative can tell us? Is there something else that comes out of this second derivative table? We know where it's negative, we know where it's positive, which tells us POIs. Thank you, Sarah. POIs, Ashley, absolutely. And Vanessa, right on the money. Where is it? Where is this POI, right? What is it that alerts you to the fact that there is a point of inflection, right? Remember, points of inflection come from a change in concavity. So when it goes from concave up to concave down, or vice versa, from concave down to concave up, that is a point of inflection, right? So where, therefore, are our points of inflection is the question that we're trying to ask. Where are those points of inflection? And how many of them do we see from this table, right? Where are the points of inflection? Does anybody see where the points of inflection? Can you give me at least one point of inflection here? Hopefully the easiest one. Absolutely. At 0, 0, there's a point of inflection right there. And how do we know that? How does Sarah know that? It changed from being concave up to being concave down. That change occurred when you went across this dividing line right here at 0. So one of the POIs is at 0, 0. We know that's one of the points that's on the graph anyway, right? That was one of the intersection points on the graph that we talked about earlier on. That was the x-intercept, that was the y-intercept. POI was there for 0, 0. That's actually on the graph. Where else do we have a POI? Thank you very much, Shashvan. Thank you very much, Sarah. Where else? You have it at the minus 5 root 3. Absolutely. So what we need to do is we need to go back to the original function and plug that in to see what the y value is, right? So I can go ahead now and put in the first one as being 0, 0, right? Coordinates 0, 0. This is looking very, very crowded, and I apologize for that. But there are other two points of inflection. So let's put that into this. So 25x over x squared plus 5. That's the original function. So I'm going to say that the y is equal to 25 times, let's go with minus 5 root 3 first, over minus 5 root 3 squared plus 25. Okay, so all I'm trying to do is get my corresponding y value. So this looks like minus 125 root 3. And on the bottom, remember that when I square this minus 5, I'm going to get 25 times 3. When I square the root 3, I'm going to get 3 plus 25. Okay, I think I did that right. So this works out to be minus 125 root 3 over 75 plus 25 is 100. All right, and that works out to be minus 5 root 3 over 4, I believe. 5 over 4. So 5 into 125 gives me 5. 5 into 100 gives me, yeah, okay. So minus 5 root 3 over 4 is what I'm getting. And if I got something wrong, please let me know. That's what I'm going to put in as my x and y value. So minus 5 root 3 and minus 5 root 3 over 4. Okay, double check me on that. I'm not going to have any room in here to do that. Okay, let me put the POIs over here. All right, I'll just list them down here. So one of the POIs, I really planned this out very bad in terms of space. One of the POIs, let's get the other POI first, and then we put them both in. So that's the first one. The second one is going to be 25 times positive 5 root 3 over positive 5 root 3 squared plus 25. It's going to be a similar answer, except this time it's going to be positive 125 root 3 over the same, over the same 100. So this time it's going to be positive 5 root 3 over 4. I did ask you for exact answers. It's the same without the negative. Okay, Richard was way ahead of me on that. Thanks, Richard. Yeah, you're quite right. You're quite right. So here are my POIs. I don't have enough room in the table. So I'm going to put all my POIs out here. POIs are 0, 0, and 5 root 3, and 5, positive, well, let's put the negative first. Negative 5 root 3, and negative 5 root 3 over 4. And then the other one is positive 5 root 3, and, oh, sorry, this is negative, and 5 root 3 over 4. Okay? All right. So I think we filled in all the information on the table by now. Right? Let me go back up and see if we did everything. We got our domain, we got our x-intercepts, we got our asymptotes, maxes and mins, POIs, concave up and concave down sections. I think we're good to go. Right? I think we're good to go. So let's see if we can make this magic happen on an actual graph now. Unless there are any questions on that, I'm going to go over to the graph now and try to see if I can put this all together. All right. So here's my grid. And one of the first things I'm going to put on there is the asymptote. There's only one asymptote, and it's a horizontal asymptote. And it has to be put on in a dotted line. So what I'm going to do is I'm going to use this tool here. I hope this is going to work. Sometimes my smartboard lets me down. So there is my horizontal asymptote. It's the same as the x. Okay, Stephen. Same as the x-axis. And then I'm going to put in my high and low points, my min and my max. All right, let me go back and see what those are. So my min was 5 and 2.5, and minus 5 and minus 2.5. Okay. So let's say this is 2, 4, 6. So 2, 4, 6. These are all negative. So positive 5 and 2.5. 5 is over here. 2.5 would be about here, I'm thinking. And negative 5 and negative 2.5 would be about here. Okay, and there's an intersection point right about here. And I'm thinking, okay, this is a maximum point. It's going to trail off and come towards the x-axis. It's going to be concave up. Let me just go back and have a look at where the concave up part is. It's going to be concave up from 5 over 3 up to infinity. Concave down. Okay, so from minus 5 over 3 up to that, and then concave down. So I'm going to put the concave down section right here. So from oh, how is this backwards here? That's really backwards. I have 0 to minus 5 over 3. It should have been, sorry, that's actually backwards. And nobody said anything to me about that. So it's minus 5 over 3 to 0. Yeah, this is wrong. Let me quickly erase that. Okay, so that's concave down. So I'm thinking That's approximately up to 0.8. So I'm thinking probably something like this. I'll use this color here. Then kind of coming down and then moving towards the x-axis here. I'm thinking coming down to this and moving towards the x-axis here. So it would, and again, I'm not necessarily doing this as elegantly as you would, right? But it does show that there's a concave down section here on this side, concave up section on this side. But it does, as it goes towards the x-axis, it's going to be concave up again, right down here. And as it goes towards the x-axis, it's going to be concave down again. So concave up in this section right here. And once you get a little bit beyond here, it's going to be concave down again. So concave up here, concave down over here. Sorry, go ahead, please. Ariana. Yeah. Okay. I'm sorry. And I didn't notice what you wrote in. Let me double check that here. So on the concave down, let me go back and look at my chart. Under concave down should have been this. Okay, so 0 to 5 root 3. That's the part, that's the one you're talking about there, Ariana? Yeah. Okay. Yeah, thank you. Thank you. Thank you very much. Thank you. So 0, 5 root 3. Yeah, okay. Yeah. And that was kind of keep forgetting. Was that down or up? Where's my table? Where's my table? So negative. So concave down, under the concave down. Right. Okay, so let's fix that. All right, check it one more time. I don't want to be lazy about this. 0 to, yeah, right, 0 to 5 root 3. Okay. All right, now does that correspond with the graph? Concave down, 0 up to about 5. Now 5 root 3 is a little bit further along, so it's probably going to be concave down up to about maybe a little bit beyond 8, so somewhere around here, where I'm pointing to right now. And kind of the same thing on the other side. And maybe I should make this a little bit more, this doesn't look so good right here. Let me kind of make that a little bit better. All right, I don't know if that's much better, but anyway. So concave down over here, and then it's going to start being concave up once you get to, as it starts to arch towards the x-axis again. Then there's a POI somewhere between where it's concave up and concave down is what I'm trying to say here. Okay, so that's, okay, so would I give you full marks for this graph? I might want to take a half a mark off myself for how really awkward it looks. But just something looking like this is fine, right? Just hitting the high points, right? You got the low point, you got the high point, you have the basic trend of the graph being concave down here. As it trails towards the x-axis, it's going to start being concave up again. Concave down over here, concave up in this section right here. It's all there, right? Not the greatest looking graph, but it's all there, right? And you can compare that when you have a chance to Desmos, but that really should only be done after the test, after you've done your homework and you just want to say, okay, did I get everything right? You can do that. All right.